Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. In this video, we're looking at Unit 1, Constructions and Rigid Transformations. This is Lesson 15 about symmetry. The learning goal for this lesson is to describe some symmetries of shapes. We have one learning target for this lesson. Once we get done with the practice problems, we'll come back, review this learning target, just to make sure you understand everything you need to before moving on to future lessons. The learning target for this lesson says that you can describe the reflections that take a figure onto itself. If you remember, reflections, we've said that it's when you flip the shape over and it creates the image. Another way to think about this is if I took a piece of paper and I folded it, then when I folded it over, both sides would match each other. And that's what we're going to be talking about in this lesson. We do have quite a few glossary terms in this lesson. So first we have assertion. An assertion is when you make a statement that you believe to be true, but you haven't gone through the steps to prove it yet. Next, we have congruent. So if we have congruent shapes, then the big thing is that the side lengths will be the same and the angles will be the same. So an easy way to make congruent shapes is to do a sequence of rigid transformations, such as our translations, rotations, and reflections. So we can see in this image to the right, to go from A to B, we have translated it down and to the right. To go from B to C, we have rotated it clockwise. And to go from C to D, we've reflected over the line of reflection, which is the hypotenuse on these triangles. The biggest thing, though, is that because these rigid transformations don't change the size and don't change the angles, then the resulting shapes are congruent. Here we have a directed line segment. So when we do lines, the lines go in both directions to infinity. So we have arrows on both ends. When we have a line segment, we have these 2 points that act as the end points of the line segment. And we're only talking about everything in between those 2 end points. Well, here we add an arrow on one end of the line segment to specify which direction it's going in. So if I just had line segment AB, we don't really know which direction that line is going. But here, by having that arrow down towards point B, then we know that this line segment is going from point A to point B. Next, we have image. So this is when we do a rigid transformation. So here we've done a translation of the triangle ABC. We've translated it up and to the right, and we've created A prime, B prime, C prime. So now we would say that ABC is the original triangle, and A prime, B prime, C prime is the image triangle. A new one that we're concentrating on in this lesson today is line of symmetry. So a line of symmetry simply means I can draw this imaginary line through a shape, and if I folded that shape along that line of symmetry, both sides would match up. So down at the bottom here, we have this hexagon, and if I folded it in half along that vertical dashed line, then the left side and the right side would lay right on top of each other. In the middle, we have this diagonal line from one corner to another corner. And again, if I folded that in half along that dashed line, then the two sides would match each other. And then again, we have this I shape, and we could fold it from top down in half and it would match. But we could also fold it left to right and the sides would match. So a line of symmetry just means you're finding this line that when you folded it along that line, the two sides would match and you could lay one side right on top of the other. Next glossary term is reflection. So a reflection is defined using a line. So here in the image on the right, we have the line M, and it is the perpendicular bisector of line segment A prime. So now A and A prime are reflections. If you folded A across line M, it would fall right where A prime is. Next, we have reflection symmetry. A figure has reflection symmetry if there is a reflection that takes the figure to itself. So several of these glossary terms we've had have all been centered around what we're looking at today, and that is we're looking for this symmetry, this ability to take a shape and fold one side of it over onto the other side and have them line up with each other, have them be the same thing. So in this reflection symmetry, we have an X. We could fold it left to right, and we would have reflection symmetry. We could fold it top down, and it would also have reflection symmetry. Next, we have rigid transformation. This goes right along with our example of congruent. A rigid transformation simply means translation, which is up, down, left, or right. So in this figure, we go from A to B using a translation of right and down. The next one is rotation. This can be clockwise or counterclockwise. In this example on the right, we rotate B clockwise to create C. And then the last rigid transformation is reflection, which is what we're going to be looking at today. And we reflect C over its hypotenuse and we create D. Next glossary term is rotation. A rotation has a center and a directed angle. It takes a point to another point on the circle through the original point with the given center, the two radii to the original point and the image make the given angle. So on the left, P prime is the image of P after a counterclockwise rotation of t degrees using the point O as the center. On the right, quadrilateral ABCD is rotated 120 degrees counterclockwise using the point D as the center. Next, this is one that today's lesson is going to be centered around. That is symmetry. A figure has symmetry if there is a rigid transformation which takes it onto itself, not counting a transformation that leaves every point where it is. So what they mean by that is we could not say, I have a square and I rotate it 360 degrees so that it lands right back on top of itself, because then every point is where it is. We're talking about taking a shape and folding it across itself and ending up with the exact same thing. So the X, being able to fold that X left and right, or being able to fold that X up or down and having it land right on itself. Next, we have theorem. Earlier, we talked about an assumption being a statement that you believe is true, but you haven't gone through the steps to prove it yet. A theorem is when you have taken that assertion and you have now gone through the steps to actually prove that it is mathematically true. Translation. A translation is defined using a directed line segment. It takes a point to another point so that the directed line segment from the original point to the image is parallel to the given line segment and has the same length and direction. So in the figure on the right here, we would say that A is the original point and A prime is the image of A, and it's directed up and right, and we know that because of the directed line segment T. Now that we've gone through the introduction of the lesson, let's go ahead and get started on the practice problems. Now we can start on the practice problems for lesson 15. For each figure, identify any lines of symmetry the figure has. So remember, if we're talking about lines of symmetry, this means we could fold along the line and they would match, or the sides would match. So the first one here is the yin-yang symbol. And the tricky thing with this is that the curves are going in the same direction and we have the coloring. So if I tried to fold it down the center and I folded left over right or right over left, I'm folding this curve over this way. And same thing here, I'm folding this black curve so it doesn't work in either direction. So that's not a line of symmetry. If I tried horizontally, I tried to come across like this. Well, if I fold this top down, then this white curve on the right would be out here. And that doesn't match. If I tried to fold it bottom up, then this black curve is going to be out here, and that doesn't match. So that couldn't possibly be a line of symmetry. And then if we tried to do some kind of diagonal in either direction, you end up with the same problem. So for this first figure, there's no lines of symmetry. Now, on the second one here, I believe this is the Scottish flag, or it at least looks a lot like it. If I drew a vertical line right down the center, then when I folded it left over right or right over left, this blue triangle on the sides would line up with each other. And these bigger blue triangles at the top and bottom, I would fold them in half and they would also match up. So I could draw a vertical in center, but I could also go horizontal. If I folded this top down or bottom up, then the big triangle at the top and the bottom would now line up right on top of each other. And the triangles on the left and right would now be folded in half, and they would also line up with each other. So we could say horizontal in center. And both of those would work out. Now you might think, could we try a diagonal? If I tried a diagonal, then when I folded it, I would be laying these kind of wider triangles on the ends on top of these kind of squished down triangles at the top and the bottom, and that would not be symmetric. So we could not do a diagonal line. So just the vertical line through the center and the horizontal line through the center on that middle one. And now on the right, we have this three-legged kind of circular triangle shape here. And the problem, again, is that the feet and the knees are bending in the same direction. So if I tried to do a vertical line through the center, then this obviously doesn't line up because I've got 2 legs on one side and 1 on the other. So it couldn't be a vertical one. If I tried a horizontal line through the center, I would kind of end up with the same thing. I've got 2 feet on the top. I've only got 1 foot on the bottom. The 2 feet on the top are out to the sides. The 1 foot on the bottom is in the center. So if I folded this top down or bottom up, that's not going to line up with each other. So that's not symmetrical. And if you tried to go kind of straight down any of the legs, that doesn't really work either. Like if we tried to go through this leg, then I end up with the same problem. I've got 1 full leg that when I try to fold it across is not going to line up with this one. And then this third leg is kind of divided between the top of the thigh on one side and the back of the hamstring and the calf and foot on the other. So obviously when I fold that over, that does not line up. It does not make it symmetrical. So this is another example where we're going to have no lines of symmetry. So the important thing to understand from this practice problem is just exactly what we mean by lines of symmetry. We're looking for that imaginary line that if I were to fold that image along that imaginary line, then when I folded that up, if it was on a piece of paper, then the 2 sides, when they touched, would have the exact same thing on both sides. And if it was a thin sheet of paper and I had drawn in like black marker, then I could fold them over and I could hold that folded up piece of paper to the light and I would see one shape because one side would be laying directly on top of the other. So that's what we mean by line of symmetry, and this is kind of an important part or an important concept to understand in geometry because there are ways to solve problems in the future based off of this understanding of a line of symmetry. So I hope this makes sense to you. If you still do have questions, please feel free to leave a comment. And let's go ahead and move on to practice problem number 2. Practice problem number 2 in lesson 15 is the last one that we'll do. Once we complete it, we'll go back, review that learning target, and we'll finish out the lesson. In quadrilateral BADC, line segment AB equals line segment AD. So I'm going to go ahead and I am going to highlight these. We're saying that line segment AB is equal to line segment AD. And we're saying that line segment BC is equal to line segment DC. So let me highlight this in another color. This line segment equals this line segment. And the line segment AC going right through the center here is a line of symmetry for this quadrilateral. That means if I fold the top down, they will line up. And if I fold the bottom up, they will line up right on top of each other. So number 1, based on this line of symmetry, explain why the diagonals AC and BD are perpendicular. So let's draw in BD. They want us to explain why we know that these two red lines are perpendicular. Well, they told us that AC was the line of symmetry. So because AC is a line of symmetry, point B will go to point D when folded over. Because this is going to happen, this means AC is the perpendicular bisector. Of the second red line that we drew, BD. And if AC is the perpendicular bisector of BD, this means AC and BD must be perpendicular. So if I know that AC is the line of symmetry, then I know that I can fold the top down or the bottom up. And when I do, points B and D are going to be in the exact same spot. Therefore, AC must be the perpendicular bisector, which means these two lines must be perpendicular. Number 2, based on the line of symmetry, explain why angles ABC and ADC have the same measure. So, if AC is a line of symmetry, then angle ABC becomes angle ADC by the rigid transformation of reflection. And the angles are the same. Because remember, the whole key of rigid transformations is that the side lengths remain the same, which they told us in the top, and the angles also stay the same. So if I can create one by doing a rigid transformation of the other, then the two must be the same. I hope this makes sense to you, but if you still have any questions, please leave a comment. Now let's go review the learning target. Just double check, make sure you understand what you needed to from this lesson before you move on to future lessons. So looking back at the learning target for lesson 15, it simply said that you can describe the reflections that take a figure onto itself. And what they mean by this is that you're able to look at a figure, you're able to determine where that line of symmetry is, and describe something such as, if I draw a line of symmetry vertically through the center point and then take the left side onto the right side or the right side onto the left side, then the figure goes onto itself. Something such as a square or a circle or an equilateral triangle. Being able to say, if we use that line of symmetry and we reflect across that line of symmetry, then the image that's created will be exactly the same. An easy way to think about this is if you've ever drawn a shape on a piece of paper in marker, and then you've folded that paper in half and held it up to a light, if you can still see both shapes both sides because they don't line up, then that means there's not symmetry. But if you've ever done it where you can see that you only have one set of lines because the two sides were laying directly on top of each other, then that is what we mean by symmetry. So as long as you understand how to find that line of symmetry, as long as you understand how to describe where it is and how you're going to take one side onto the other in order to create this symmetry, then that is how you describe reflections. We reflect this over this line of symmetry, and it gives us this reflection. So as long as that makes sense to you, then you are exactly where you need to be moving forward. If you found this video helpful, please give it a thumbs up. If you're interested in seeing more of these, then in the bottom left, you should see another of my videos that YouTube is recommending to you. In the bottom right, you'll see the subscription button for the channel. It really helps a lot when you subscribe. And as always, you can leave a comment below, and I look forward to seeing you in the next lesson.